I've only just started. It's a bit slow, but we'll get there. Try on.
Yeah.
Hurry up.
Okay, so where did we go today? There's a Red Cliff. Mount Coolum. Hour and a bit drive. 2 hours and a bit drive. This big hunk of rock here. There's a house for scale. Big, huge block of Comendite with some other stone down here, which I'll talk about later. So that's the main track. But first we went from the car park, wherever that is, around here somewhere. We went around, which I don't recommend, and you're not allowed to go near the quarry, where the rock climbers are.
Where the Kerrigan's house is before.
Alright.
So I can
So there's people climbing up right now?
yeah, I just passed and said, oh, this is my backyard.
Oh, that's a dream, isn't it?
Oh,
To live here.
I love it.
So thanks to that lady who has one of those houses that are right next to the rock, apparently, and she told us basically got us on the right track, and then said when you hit the danger sign, go to the danger. All right. And that's how we got to the rock climbers cliffs. So the main thing we were here to see was these columnar jointings, they're called. So these tall, perfect sort of looking rods of basalt, they usually are, but there can be other sort of rock types, even sandstone. And we'll go into what sort of rock it is in a second. And they're caused apparently by perpendicular cooling. And so we'll talk about that a little bit later too. But just in this bit here, that are just it's unusual that they're actually horizontal. So normally they're perpendicular, vertical. And so the argument is that this material, which is comendite, is super viscous, unlike basalt, and just really flowed really slowly, and so it flowed at different angles. And so the angle of cooling was here, not straight up and down, because it was slowly flowing or something. I don't know. I'm a chemistry teacher, all right. So that's that. I'm getting all my information from the latest published paper on the topic, which is 1985, and I don't think anyone's going to pay anyone anything more to do any more research on that. And that's the most recent published paper. A lot of geological features have no published papers on them, so count myself lucky I've got one for this. And you can see in this diagram here that they are radially dipping around the mountain as these little black arrows show. So here's just one of the columns near the hikers track, the first track we went on. It's just really smooth and the angles are just all perfect and sharp. So that was a column that fell down that I thought was really cool. And here is at the top of the track on the second walk, and you can see all the columns going down horizontally. And it's mostly part of the stairs once you get about halfway up. So I'm just climbing them up. I'm climbing up these horizontal columnar jointings is the term for it. And so you'll see lots of them close up when you do the main track, which we did second. Now on the way to the rock climbers cliffs. There's the quarry. That's the best photo I could get. That's the closest it is to vertical, which it's meant to be. And this is at the rock climbers cliff. So there's a human for scale. I tell you what's really cool. If you've watched the Rhyolite video, you'll know that I'll get into the Comendite in a second, but you'll see that there's lots of vesicular. Look at it, it's huge. So much of it. And can't see the columns too clearly. I'll show you the other photo. So here's another person, a human for scale, and there's all the gas vesicles in this quickly um, solidifying igneous rock. And over here, I think you can start to see, yeah, here you can see all the hexagonal shapes and the horizontal columns, and they're meant to be vertical. Okay, so the other thing I don't get is why it splits in the hexagonal pattern, and apparently it's the most easiest way to cause stress relief. So I'll leave that to the physicists or whatever. It happens even in clay. You can see it happening here. Hexagonal is apparently the best splitting, but it can be 3 to 8. So this one here is the biggest one I could find. It was 6. 1, 2, 3, 4, 5, 6. And that was at the Rock Climbers Cliff. And these ones are on the main track. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4. I don't know. 3 to 8 sides for stress relief. Okay, now we are going to go into what type of rock it is, the two types of rock. So the Comendite here and the Hornblende diorite porphyrite. So this is the rabbit hole that is geology. So what geology does is they've got this continuous data scale going on here, and then for some random reason they'll break it up at certain points and give them names. Um, it's a little bit crazy to me, but so there's basically endless names. There's like 5,000 minerals anyway, but besides minerals, the rocks here have got infinite number of names. You could break this up into 1,000 little pieces if you really wanted to, and add another 1,000 names here. So yeah, that's what geology is. So the red is plutonic. Um, so the plutonic is the stuff that's inside the ground and has large crystals and cools slowly, and the volcanic is the stuff that is extrusive and has small crystals. So this is the same thing, granites and rhyolites, but this has the large crystals, this has the small crystals. And so what we're dealing with is Comendite. And so Comendite is basically a rhyolite. So it's volcanic, it comes out, it's got a defined matrix. But it's very quartz rich because it's way up here, almost to the quartz end. But it has slightly more sodium and potassium, which is the alkali, than aluminium. That's the only way it's different from rhyolite. So it's basically rhyolite with more potassium and sodium than aluminium compared to a rhyolite. Okay, so that's the rabbit hole. So the cube APF is meant to be for the intrusive, and the TAS is for the extrusive. So why did I just use the QAPF when I should have used the TAS? I don't know. Let's move on. All right. The cool thing is it's very viscous, and it's a light blue color. So it's kind of cool. It's a light blue color. It's not that hornblende, which is like a dark blue. It's like a basalt that's been undergone metamorphosis. This one's like a rhyolite, but it's blue, not pinkish or whitish. And so you can see the fine matrix here. That you can't see this here, but that's about 1 centimeter. You can see the flowing like rhyolites have, and that's just a larger piece for scale. The thing I really like is because it's high in silica, it sounds like glass. So listen to this.
Wow. You have to teach us, yeah.
And so the other rock that you're going to see is the Hornblende diorite porphyrite, and the main track is up on this side up here. So you have to sort of walk around. You're not going to see it on the main track. You have to walk around to the cliffs. And apparently the largest deposit is over here on the west side, which I'm not going to walk all the way over there. But I managed to find some just on the way through. So that's what we're looking for. So what's hornblende diorite porphyrite? So porphyrite, um, so phaneritic is just large crystals. Aphanitic is it's all made up of really fine crystals, and porphyritic is a mix. So there's large crystals in a fine matrix. So there we go, large crystals in a fine matrix. So there's porphyrite done. Hornblende, let's do that because that's the hornblende there. So let's go to the Bowen's scale. Let's not. Let's go to diorite. So diorite is here. So usually it's rhyolite, andesite, basalt. So it's getting white, grayish, black. And so diorite is plutonic, and so that would be fine crystals, and diorite is the red plutonic, so it's large crystals. So a grayish rock matrix, diorite. So where are we now? grayish matrix, large crystals, and they're the black ones. So we would expect to be more around here on the Bowen's reactivity scale, not the mafic minerals, the blocky black ones, more the long, fine black ones, more down this end, the medium to light. So that's the andesite rhyolite, which is Comendite, which is what we're dealing with. So as you would expect, it's the black fine ones, not the black blocky ones. So Hornblende and Amphibole are the same name. You know, I'm not really a huge fan of English. I think it gets in the way of science, but we have to deal with it because that's what geologists are entrenched in. And so that's the hornblende, the amphibole, the black long crystals. These are great too. See that scale 1 to 10? That's 1 centimeter. So they're kind of huge. There's a finger there. I'm not giving you the finger or anything. Um, that's my pointing finger. And so there you go. That's the matrix. That's it. Hornblende. There's the hornblende. Porphyrite. There it is with a diorite matrix. God help us all. All right. That's geology. Okay, the last issue I'm going to raise in this video is how they think this thing formed. They think it's a laccolith. And so a laccolith is this thing down here. So this is that's still molten, but that's hardened. And then that's within deep within sandstone, and then it eroded away. Um, so that's how they think that formed. Could be true. That's the theory. Makes no sense to me. This is 220 meters high, and this is, the other laccoliths are like 500 meters high. So they're saying that pretty much the entire southeast Queensland was covered in over half a kilometre of sandstone that's eroded away. Where did it go, and how did it erode away? Just seems crazy to me, but that I'm just letting you know that's what the theory is, okay? And that's the last issue I'm going to raise. So this is me mimicking what most people are doing, and so going up this mountain, going a little bit too fast. The track is absolutely beautiful, best track I've ever seen. The rock work on the whole way up is immaculate, and the view is good. Now at the top you can see quite a lot of weathering. So you can see here there is the iron weathering. You can see it's gone all a bit sandy, so it's all sanded out for clay. It's gone this like weathered color, and you can see it's breaking up here. And so you can see in this, so you can see here that you can even break it with your fingers. It's just gone into, it always feels like a sandstone, and it's just so weathered and quite crumbly. And you look at the track, it kind of looks very broken up. You can even see how fine the clay is all on your hand. And just the last thing, because most things have a little bit of iron in them, you just don't trust anything that's a brown rock. I think I found like a basalt layer here. There's a chip off this brown rock, and it's black, and there were bits of basaltish, just small bits here around the place. And this is at the top. So this is at the Climbers Cliff, and this one's at the top. So this is the first thing we went to, and this is the main track, second. And there's a chip off this brown block, and you can see the white um, Comendite there that's been actually quite weathered, maybe to clay. So don't trust brown rocks.